Hello everyone, I am Shupatra Panchal, Assistant Professor, Department of Computer Science and Engineering, BADSVP Dr. PG Halkatti College of Engineering and Technology, Vijaypur. So in the last class, we have discussed something about key management, and in that we have discussed UKPT on the generic schemes. So in today's class, we'll be discussing about something about key storage. So how we can store key based on the requirements. So what is exactly key storage? Key storage means secret keys need to be protected from exposure to parties other than the intended owners. So it's very simple meaning. So those who are authorized users, only authorized users can use the keys at the time of transmission of any data, any kind of data. Such keys needs to be extracted and used for the purpose of transmission. Then once again the same keys are going to be stored in the same particular environment. So that is what secret keys needs to be protected from exposure to parties other than the intended owner. It is thus very important that they are stored securely. So there are some modules here. So in that one module is hardware. So how we can store the keys, something about in the form of hardware security models. So the securest hardware storage media for cryptographic keys are hardware security models. That is what I can call it as a HSM. So these dedicated hardware devices that provide key management functionality are known as uh, tamper resistant devices, so which can store the keys. So many HSMs can also perform bulk cryptographic operations, often at high speed. An HSM can either be peripheral or can be incorporated into a more general purpose device such as point of sale terminal. So these are all different factors which deals with hardware security modules. HSMs are mechanisms for the secure storage of cryptographic keys. HSMs are often used to enforce other phases of the key lifecycle. The keys stored on HSMs are physically protected by the this particular term is very important. Physically protected by the hardware. If anyone attempts to penetrate an HSM, I mean, if anyone wants to hack a particular key, so for example, to extract a key from the device, tamper resistant circuitry is triggered, and the key is normally deleted from the HSM's memory. So that's what. There are various techniques that can be used to provide tamper resistance. These include, so you can see there are many of the techniques in that microswitches. These are all some of the hardware modules, hardware devices which can be used to provide tamper resistance. So microswitches, electronic mesh, resin, temperature detectors, light sensitive diodes, movement or tilt detectors, voltage or current detectors, security chips. These are all different techniques for tamper resistance. So how exactly we can store the keys on an HSM? Key storage on an HSM. There is at least one key, often referred to as a local master key. We can call that as LMK, that resides inside the HSM at all times. Some HSMs may store many LMKs, I mean many local master keys, each having its own specific use. Any other keys that need to be stored can either be, stored inside the HSM, stored outside the HSM, and keep producing local master key. This is all how we can store the keys here using hardware security modules. So next, this is something about how the keys are going to be stored in the hardware security modules. Next concept is public key management. Then is public key management. So what we need to provide, the more important factor is certification of public keys. So before that you should know, So what is exactly public keys, private keys, where we can use public and private keys? I think public and private keys we can use it in the uh, something else, public key encryption. So where you can one user can use public key and other user can use private key for encryption and decryption. The best example for this is RSA. The most popular mechanism for providing this assurance of purpose, the public key certificate. So motivation for public key certificates. Suppose that I think you know already the users or actors in this particular entire subject. That is Alice, Bob, and Charlie. So you know better. So the role of each user or each actor. Suppose that Bob is at the receiving end, Alice is at the sending end, and always Charlie wants to hack some data in between. So that is what the user. Suppose that Bob receives a digitally signed message that claims to have been signed by Alice, and that Bob wants to verify the digital signal. Here, very simple example. Bob receives a digital signed message that claims to have been signed by Alice, and that Bob wants to verify the digital signature, which is only sent by Alice. So in this public certificates, we need to provide some of the factors here, and in that, very first point is providing assurance of purpose. So we need to give the, I mean, we are going to something, some users want certificates, public certificates. In that case, they should provide the purpose, that is assurance of purpose. The above scenario requires the first point, provide a strong association between public key and the owner of that key, the entity whose identifier is linked to the public key. This is first point. Strong association should be there between public key and the owner of that key. Provide a strong association between a public key and any other relevant data. So two things are very important. One is there should be a strong uh, bonding or strong association between public key and the owner of that key. I mean, it's very simple, public key and owner. Second one, strong association between public key and any other relevant data which is actually required for encryption, such as expiry dates and usage restrictions, all those. So next point, providing a point of trust. So first one we discussed, that is purpose. Purpose in the sense we need to provide a relationship between key and owners. And second one is providing a point of trust. The problem in designing any public key management system is that we need to find a source for the provision of the strong association between a public key value and its related data. So how we can provide? Using a trusted directory. An approach to providing assurance of purpose for public keys is to use a trusted directory which lists all public keys next to their related data, including the name of the owner. So this approach has several significant problems. So what are those problems actually? So universality. The directory has to be trusted by all users of the public key management. This is first point. Should be trusted by all users. Availability. The directory has to be online and available at all times to users of the public key management system. Should be available. Then it should provide accuracy. The directory needs to be maintained accurately and protected from unauthorized modification. No one should modify uh, that particular directory. This is what how we can provide using the trusted directory, and these are some of the significant problems we can face it in uh, key storage, that is key certificate, public key certificates. So the next very important point, what actually the public key certificate contains. That is contents of a public key certificate. A public key certificate contains four essential pieces of information. One is name of the owner, public key value, then validity time period, then after that, very important one, signature. So name of the owner. The name of the owner of the public key. This owner could be a person, device, or even a role within an organization. Then public key value. So public key value itself, this is often accompanied by an identifier of the cryptographic algorithm with which the public key is intended for use. That is what we can have is public key values. First one is owner, then its value, then uh, up to what extent, that is the up to what duration the particular key should be existed, that is validity time period. So this identifies the date and time from which the public key is valid, and more importantly the date and time of its expiry. Signature: the creator of the public key certificate digitally signs all the data that forms the public key certificate, including the name of the owner, public key value, and validity time period. Once again, I'll just read it. You can just concentrate. The creator of the public key certificate digitally signs all the data that forms the public key certificate, including what it contains: owner, public key value, validity time period. So all this is what we have signature. So in the next class, we'll be discussing about certificate creation. Thank you.